Hello everyone, welcome back. This is Mr. Sen. So it's continuation of our differential applications. So in this problem we're being asked a question that says that for a particle moving in a straight line, its displacement s meters from a point O on the line is given by s being equal to t squared minus 5t plus t plus 6, where t is the time in seconds from the start. Find the initial distance of the particle from the origin, which is O. Find its initial velocity and acceleration when it is at instantaneous rest. At what time or times at the start it passes through O, the distance traveled in the first 3 seconds. Okay. Let's see to it that we try and solve this. So to find the initial distance of the particle from the origin, we need to find the value of s when the time is equal to 0. So if we substitute for t in s being equal to t squared minus 5t plus 6, we'll end up having s being equal to 0 squared minus 5 times 0 plus 6, which implies that the initial distance of the particle from the origin will be s being equal to 6. Numerator 2 is asking us to find its initial velocity and acceleration. Now to find its initial velocity, what we have to do is to differentiate the displacement function. So what we'll do is that since we're having s being equal to t squared minus 5t plus 6, if I set the s over the t, change in position over a period of time, I will get my velocity, which will be 2t minus 5. Therefore, v is equal to 2t minus 5. Now, at the initial point, it implies that time is equal to 0. This implies that v will be 2 times 0 minus 5, and the initial velocity will be minus 5. For the acceleration, since we're having the function of v in terms of t as 2t minus 5, I can differentiate this function with respect to time, and the change in velocity over a period of time is what we call the acceleration, and is equivalent to 2. Even if I had to say that at time being equal to 0, what would be my acceleration? It will still be what? 2. Now, in the third portion, we need to find what would be the particle, or let me say, what is its these questions are not written in the correct form. Okay, so when it is at instantaneous rest, what happens? So the particle will be at instantaneous rest when its velocity is 0. So if we get the velocity function, which is equal to 2t minus 5, and set it to 0, where we say let v equal to 0, we end up having 2t minus 5 being equal to 0. And if we solve for t, we have 2t being equal to 5 divided by 2 divided by 2. T is equal to 5 over 2. Now, what this means is that the particle will be at instantaneous rest at time being equal to 5 over 2 seconds, provided that the units, 5 over 2 seconds. Then for numero 4, it says at what time or times after the start. Okay, so for this one, we need to find the time or times after the start when the particle was passing through the origin, which is O. So we need to solve the equation for the position, which is the displacement given as s being equal to t squared minus 5t plus 6. So what we need to do is to solve the equation by letting s being equal to what? 0. So if I let s be equal to 0, I have t squared minus 5t plus what? 6 being equal to what? 0. So I will find the time, or the time it took after the start when it passed through O. So using the sum and product, I have minus 5 and 6. So I have 2 and 3, of which both will be minus. So I have t minus 2 and t minus 3 being equal to what? 0. So I'm having my first time to be 2 and my time 2 to be equivalent to what? 3. Therefore, the particle will pass through O at time being equal to 2 seconds and time being equal to 3 what? Seconds. Then to find the distance traveled in the first 3 seconds. To find the distance traveled by the particle in the first 3 seconds, what we need to do is to find the distance, since we're having the position s being equal to t squared minus 5t plus 6. We need to find the position in the first 3 seconds. Then again, we need to find the position when time is equal to 0. So we need to find s when time is 3 and subtract from s when time is equal to what? 0. So if we substitute, let's say where t is equal to 3, then s is equal to 3 squared minus 5 times 3 plus 6. So s here will be equivalent, if you put 3, 9 that, we end up having a case where you have 9 minus 15 plus 6. And this in turn will give you what? 0. Then again, if you take it where the time is equal to 0, then the position will literally be what? 6. So what will happen is that if we substitute t into the equation for s, to give us a displacement after 3 seconds, which is 0 meters in this case. Therefore, the distance traveled by the particle in the first 3 seconds is going to be equivalent to the absolute value of the difference between the initial displacement and the displacement after 3 seconds. So the distance traveled is equal to the absolute value of 0 minus 6, which will be 6 what? Meters. So the particle traveled a distance of 6 meters in the first 3 seconds. Alright, thanks for watching. Don't forget to like and subscribe.